Welcome back to Mr. Hassan's Maths channel. Now this is a question I've been requested to answer from a very old paper, which is a June 2005 Core Mathematics C2, the old GCE papers, which is now corresponding to the new P2 papers from the Edexcel examining board. And this question here is about differentiation and its applications. So this question is telling us about this shape, which is a plan of a stage in the shape of a rectangle joined to a semicircle. So we know this is a rectangle because they told us, and we know this is a semicircle because they told us. The length of the rectangular part is 2x meters, as they've shown, and the width is y meters. And the diameter of the semicircle part is also 2x meters. It's like the other side of this rectangle. And the perimeter of the stage is 80 meters. The perimeter, the length all the way around the outline, is 80 meters. So we got to show that the area a meter squared of the stage is given by this equation. So I've got a little copy of the diagram, so I keep going up and down, giving everyone a headache. So here, basically, they always give us, in this type of question, 2 bits of information about the situation. So they told us about the perimeter, and they've told us about the area. Okay, those are the 2 quantities we have to deal with in this shape, the perimeter and the area. All right, so in the end, we have to have this expression for our area. So area equals 80x. Well, let's just start off by writing down what the area of the shape is. The area is made of 2 parts. You have this rectangle. So the area of the rectangle is going to be the length times the width, which is 2 times x times y, plus the area of the semicircle, which is now the area of a semicircle, or area of a circle, is pi r squared. Now the radius of this semicircle is going to be basically a half of the diameter, which is x. So it's half of the diameter. The diameter is 2x, so the half of that is x. So the radius of this is x. So area equals pi r squared. So r equals x. So this is going to be plus pi x squared, but divided by 2. Because it's a half of the area of a circle. It's a semicircle. So that's an expression for the area. Now, that doesn't look very much like this at all at the moment. Okay, so the only thing that looks the same is this pi x squared over 2 part. Now, the reason being is because they also told us something else about the perimeter of this, about this thing, which is its perimeter. See, in this expression, there's no y. In this expression, there's a y. We have to basically replace the y so that it's in terms of x, and then we can have an expression which has just x, which should give you this. So how does that take place? Well, we're going to find the perimeter of the shape. Okay, let's think about the perimeter of the shape. The perimeter of the shape is the length of the outline, which is y plus 2x plus another y, so that's 2x plus 2y. All right, now we don't add another 2x here because this is inside the shape. Normally a rectangle have 2 times the length times 2 times the width, but this length is not inside the shape. Perimeter is the length of the outline. So don't make the mistake of finding the perimeter of this rectangle and adding to it the perimeter of this semicircle. You only need the length of the outline. So 2x plus y plus another y plus this arc length. Now the arc length here, from there to there all the way around, is a half of a circle. Now the circumference of a circle is 2 pi r. Now what we want is a half of that circumference. A half of that circumference, so that's going to be 2 pi x over 2, which is plus pi x. So here we're going to have plus pi times x. All right, that is the circumference of the circle. All right, so we got the perimeter is equal to y plus 2x plus y plus pi x, and that gives us the perimeter of the circle. Now what we're going to do here to make us get this expression is we're going to make the y here the subject, and then replace the y with what it's equal to in this equation. And what we know is the perimeter is equal to 80. So I can take, can get rid of this now. I can take this 2x plus 2y plus pi x and make y the subject. Now what I'm going to do here is I notice that there's a 2y here. So I can actually make 2y the subject. That would be more sensible, so I don't have to keep dividing by 2 then multiplying by 2. I can just make 2y the subject. So 2y as a subject would be 80 minus 2x minus pi x. Just take away 2y and 2x from both sides. And what I can do here, the area it's 2 times xy, which is like, you can say x times 2y, plus pi x squared over 2. Now I can replace the 2y with 80 minus 2x minus pi x, and then that will give me x times, I can replace the 2y with 80 minus 2x minus pi x, and I've got plus pi x squared over 2. Right, now just keeping in mind what we have to show, okay, it looks like I should really expand this bracket here to, you know, be able to bring the like terms together and then try to simplify as I have. That's going to be x times 80, which is 80x, which we have there, that looks looking good so far, minus 2x squared minus pi x squared plus pi x squared over 2. Okay, so far it's okay, looking okay. Now what I can do here is I can combine these two like terms together. Okay, so I'll just do that over here. So I have a equals 80x minus 2x squared, and this is going to be minus 1 pi x squared plus a half pi x squared, which is minus a half pi x squared, so minus pi x squared over 2. Okay, now it seems like what they've done here is they've taken out x squared as a common factor from these two terms. So let's do the same thing. I'm going to have 80x, I'll put the x squared here, minus x squared. Now minus x squared times 2x times 2 gives us 2x squared, that will be right, and minus x squared times plus pi over 2, that will give you minus pi x squared over 2. Take the minus x squared out, if I have to write this as 2 plus pi over 2, right, because you're going to have minus 2x squared minus pi x squared, and that's, I think, exactly what we had to show. 80x minus 2 plus pi over 2 x squared. So we can just write it in the end exactly how they want it, with the x squared written on that side, just to show that we've got the same thing. So this is minus 2 plus pi over 2 times x squared, and that's what we had to show, and there's the answer for part A. Okay, that's the answer to part A of this question. We've shown that the area is given by this expression here. Okay, so again, there's always two things. One is the perimeter, one is the area. We write expressions for both of them. The perimeter, we know its value is 80. Okay, so we can then make an equation. And then in this case, I made 2y the subject because I saw a 2y in that expression. I can replace the 2y with what 2y is equal to and simplify it to how they want you to simplify it. And you got your answer. All right, now for part B. For part B, it says use calculus to find the value of x at which a has a stationary value. Okay, the value of x at which a has a stationary value. So a stationary value is when the gradient of this curve is going to be 0. So when the change of a with respect to x is equal to 0, is when you have a stationary value. So we got to find what dA dx is first. Now dA dx, we have to, an x term, you just lose the x, that's going to be 80. Then here we have to multiply by the power. Remember, this is just, this whole thing here is a constant in the bracket. Okay, the whole thing in here is a constant. So I'm going to put minus 2 times 2 plus pi over 2. So multiplying the constant by 2 and then taking 1 from the power. So that's that's how we can differentiate that. Okay, so just multiplying this constant by 2 and take 1 from the power. And we know dA dx equals 0. So we're going to equate this to 0. So we have 80 minus 2 times 2 plus pi over 2 times x is equal to 0. What I can do is I can add this to both sides. So I have 80 equals 2 times 2 plus pi over 2 times x. Divide both sides by all of this. So I can say x equals 80 over 2. Well, I can just actually multiply this together. This is going to be 4 plus pi. 80 over 4 plus pi. Because if I multiply this bracket out, I'm going to get 4 plus pi. So 80 divided by 4 plus pi is x. So x equals, we can take the calculator and just find what that is. 80. Oops. So wrong mode. Put it in the right mode. 80. Oops, not 8. 80 over 4 plus pi. Put it in this exact form to get a more accurate answer. That gives us 11.2019. 11.2019 goes on. So x equals, they don't tell you how to find it, so I'll put 11.2. Okay, and x is in meters, I think. Yes, it's in meters. So 11.2 meters is the answer there for part B. Now on to part C. It says prove that the value of x you found in part B gives a maximum value of a. So we need to find d squared a dx squared. So first of all, let's write out what dA dx is. So we got dA dx is equal to 80 minus 2 times 2 plus pi over 2 times x. Okay, so dA dx, d squared a over dx squared, the second differential. Okay, we're going to have d squared a dx squared is equal to, well, the constant becomes 0 when you differentiate this, and the x term is dropped, so you're left with minus 2 times 2 plus pi over 2. Okay, so we can see that this only gives you a constant value which is negative. Okay, so we can say therefore d squared a dx squared is less than 0. So we can say therefore we have a maximum. Okay, this thing only ever has one turning point because it's quadratic, and that quadratic has got a negative coefficient of x squared. So we find the second differential, we see it gives us a negative value. That means this curve is got a maximum because the gradient is always decreasing. It's always getting less. Okay, the second differential is less than 0. At a maximum, the gradient is always decreasing. It's going from positive to negative. So for this graph, the gradient will always be decreasing as you're going from left to right. It's always going to be getting less and less and less. It starts off positive and it becomes 0, then negative all the way. So that's why for all values of x, this is going to be something where the second differential will be something which is negative. All right, so there's the answer to this question, part C. Now we've got part D to do. It says calculate to the nearest meter squared the maximum area of the stage. So we've got to take our equation from the beginning. We know that when x equals this value 80 over 4 plus pi, when x equals 80 over 4 plus pi, this is the maximum value, the value of x that gives a maximum. So we can say a equals 80 times 80 over 4 plus pi minus 2 times, minus bracket 2 plus pi over 2 times 80 over 4 plus pi all squared. Okay, so I can actually take this value, I can store it as a, and I can just use that value easily in the calculator now. I can say 80 times a, so 80, just recall that same value, 80a minus, you're going to have 2 plus pi over, 2 plus pi over 2, close that bracket, times, okay, times, recall a, but squared. Okay, that's the same thing. That's 80 times a, 80 times 80 over 4 plus pi, minus 2 plus pi over 2 times 80 over 4 plus pi squared. The a is equal to 80 plus 4 over 4 plus pi. I save that in the calculator. So that should give me the maximum area, which is 448.079. 448.079. So it says to the nearest meter squared. So the area is going to be 448 meters squared to the nearest meter squared. So there's the answer to part D, and that concludes this question. Which is question number 9 from this paper, June 2005, from the very old C2 paper here. but it's still relevant to what we're doing now because P2 has this topic in it. So that's question that student asked. Thank you for watching. I hope that was clear. Other questions from this paper, if I ever get asked to answer a question from this paper again, I will put in the playlist that should appear in this region here. Other questions from P2 differentiation can be found in this link over here. I might make an extra playlist as well just for this topic of optimization problems, and the link over here, and you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.